the baseline reference for our simplified analysis is defined as demonstrated in previous lecture, it is possible to simulate the effect that an economic shock have on the given economies. To make a practical example, let's consider the International Energy Agency's 10-action proposal plan for reducing the reliance on Russian natural gas that is surely a hot topic for the energy sector at global level at the time this video is being recorded. To circumscribe our attention, we shall consider only Action 2 and 9 that are devoted to replace Russian supplies with gas from alternative sources and to encourage a temporary thermostat adjustment by consumers. Please consider that IEA actions are also reported with some numerical information that we can use to quantify the economic shock for the exercise. In these slides are reported all the relevant information to translate the IEA Action 9 into relevant numerical inputs that can be used in the Excel file to make our calculation to measure the impact of this action. Opening the MRIO S1 sheet from our Excel file, we can firstly address the economic shock caused by IEA Action number 9. That is the simplest and most straightforward to be simulated by using an input-output model. First of all, it is necessary to translate the numerical inputs obtained from the IEA declaration into economic and physical values coherent with the database we have from the baseline described in previous lecture. Therefore, assuming some conversion factors, it is possible to quantify the amount of gas final demand that is avoidable by lowering 1 degree Celsius space heating and the associated emission reduction potential.
Perfetto.
These are the values that we can use to populate the shock matrices. In this specific case, we are considering an economic shock that is affecting only final consumption patterns. Hence, we have to address our attention to the related matrices. In the IEA statement, it is explicitly reported that this action is aimed at reducing EU exposure from Russian natural gas importation. Therefore, it is possible to assume that the overall reduction of EU household natural gas consumption only affects Russian importation. So, where EU household final consumption intercepts Russian natural gas production, we assume a reduction of the equivalent amount of natural gas quantified in monetary terms. To this reduction is associated also a decrease of CO2 emission due to final uses, heating in this case. And we can put with negative terms this value in the dedicated place. So, adding up the shock matrices to the baseline, it is possible to quantify the impact of this shock both from the production-based accounting and from the consumption-based accounting approaches. Looking at the result from the PBA perspective, we can see which are the sectors that are affected by the Russian natural gas consumption reduction. Of course, this shock has a positive impact in terms of CO2 emission reduction, but this comes with the drawbacks of a loss of value added and job position not only in Russia but also in the rest of the world and Europe. In addition to that, we have to consider the amount of emissions avoided at household final consumption level. This value has to be discounted from the result to obtain the total CO2 emission reduction value. Coming now to the second exercise, we can refer to Action 2, that is slightly more complicated since it does not involve final uses but other European industrial sector, that are expected to reduce their dependence from Russian natural gas supply. More specifically, the foreseen Russian natural gas dependence reduction correspond to approximately a 3% reduction of Russian natural gas for every unit of output from each European industry. Coming now to our Excel file, we can open the MRIO S2 sheet and see the implication that this reduction has in terms of impacts. In the shock matrices, we have to numerically consider that the EU industry requirements of Russian natural gas will be reduced by 3%, and we can act directly on the technical coefficient computed for the baseline, quantifying their variation in this way. Nevertheless, to guarantee that this change should be sustainable in the future, it is necessary to assume an equal increase of natural gas importation from countries of the rest of the world. Therefore, we define in the shock matrix an equal increase in the dedicated row. As anticipated, this shock does not involve household final consumption. Thus, these are the only changes we have to impose to the economy. Following the same procedure as done for exercise 1, it is possible to obtain the impact results associated to this shock. As expected, this shock does not present any impact information from the consumption-based accounting approach. This because no changes in the final consumption pattern are considered. Nevertheless, the changes simulated for the transaction coefficient matrix cause a variation in the outcomes from the production-based accounting perspective, with a contraction of the 3 impact quantities for the Russian sector and some positive terms for what concerns sectors in EU and rest of the world. Notably, if we have to look to the aggregated global values, it is possible to infer that this shock is capable to produce a net reduction of CO2 emissions, keeping the balance of payments, value added, almost unchanged at global level, but producing a positive impact in terms of new job opportunities, as this number shows us.